Hello again, students. I wanted to talk to you about a warm-up problem here. Have you start off with the, if I tell you I've got the set of power set, I should say, of natural numbers and symmetric difference operation. Do you recall how to complete these? Hopefully you recall that this one's going to be a set of 1, 2, 4, and 5. Remember, symmetric difference is the union of the sets minus their intersection. In this case, the intersection of these is the 3. Now, problem 2, there is nothing in the intersection of those two, so it's just their union. And then, of course, everything is there's on number 3. Everything's in there. Why'd that give me a hexagon? No idea. I was trying to make it, say, a circle. There we go. And yeah, just trying to make a nice little empty set symbol for you there, because the union minus the intersection, when the sets are the same, yeah, they canceled out completely. Good. So, continuing our discussion with ordered groups, and I want to talk about positive and negative elements, which of course sounds pretty basic, but as you're going to see, it's the rules can get a little bit confusing the second you start talking about something other than the less than relation. So first of all, let me scroll on down here, and again we remember when we're talking about converse of less than, obviously that's going to be greater than. Converse of addition is subtraction. Of course, you remember those things here. Good. Hold that thought. When I have an ordered group, we'll have our order preserved when I take the inverse operation. So in this case, if A is less than B, A minus C is also going to be less than B minus C. Easy enough. And of course, by if I flipped it around, if I had the sorry, it's going down here. Yeah, that's right. If I have A minus C is less than B minus C, then I should be able to flip it around, and A minus C would be greater than B minus C if it was the greater than relation. That's where I was going with that. Okay, so now let's take a look at some examples here from this ordered group. So obviously, and I've kind of demonstrated this to you before, so hopefully this you're ready to answer this. Let's say, for instance, we know 5 is less than 7, but if I flip them up, change their signs, now it's negative 7 comes before negative 5, right? So same thing goes with the rest of these here. 3 1/5 is less than 4 2/7. Well, fine. C, if one's any negative, of course, is going to be less than a positive, but if I flip it around, negative 1/2 will be less than what's going to wind up being positive 8/5. So if we know that S with addition less than, we know that that's some ordered group, then we've established if A is less than B, then negative B is less than negative A. By monotonicity, of course, this property still holds, which gives me 0 is less than B plus negative A. And again, I can introduce monotonicity to show, long story short, I got negative B is less than negative A. Again, do you see where we started with this? Right? We started with A is less than B. When we tagged them both with negatives, the whole thing flipped around. And there's the rules for it. And again, I mentioned this before, so hopefully you were ready for this. You saw this coming. Okay, so ordered group properties that relate to exactly what I just said, including number 4. These are going to be proven in these exercises starting with 46 right here. So we're going to prove group property number 5. So starting with suppose that 0 is less than A, then by ordered group property, we're going to say 4. Take 4, that's where we flip the signs around. Negative A is less than negative 0. But negative 0, of course, is the 0 element. And so, yeah, we've proven it. Exercise 47, proving ordered group property 6. Fine. Suppose that 0 is less than A and 0 is less than B. Then by ordered group property 2, we know 0 plus 0 is less than A plus B. I say 0, it's really 0 elements of S, but you understand. And of course, we know this result follows because 0 is the neutral element. All right? 48, proof of order group property 7. If A is less than 0 and B is less than 0, then their sum is going to be less than 0. And that makes pretty decent sense if you must know. Yeah, by order group, because by order group property 2, we know that A plus B must be less than 0 plus 0. And this follows because 0 is the neutral element. Again, excellent. Neutral element. Cool. All right, so again, that last one's just a nice demonstration here of this. A plus B is less than 0 if A is less than 0 and B is less than 0, of course, right? All right, so this is the part where it gets a little confusing when we talk about positive and negative elements on a set. So let me bring this up here. I'm going to highlight this in yellow. Hopefully this is coming through. A is a positive element of an ordered group if and only if 0 relates to A like that, which of course, if you think of it as less than, so yeah, it makes perfect sense. All right, and then of course, logically, A is a negative element if A is less than 0. Now, hopefully, you look at that and say, well, yeah, of course. What's the catch? Hopefully you're ready for it. It comes in down here. Oh, I'm sorry, I forgot to mention these two things. That's going to be the shorthand for saying the positive elements versus the negative elements on S. Okay, so we're going to now introduce the notion of, quote, positive elements. So we understand here X is a positive element of this ordered group if and only if 0 is less than X. All right, and X is going to be considered a negative element on that ordered group if X is less than 0. Now, this makes pretty good sense, I would hope you would think, but nevertheless, it's something I want you to, naturally assume, sure, whenever you're talking about orderings on rationals or integers, and know that we're not going to bother mentioning linear order when talking about positive, negative elements. And so that is to say, if we say Q plus, obviously we're talking about this, the positive elements on the ordered grouping of positive rationals. And this will be what we'll write for negatives. And again, as you're looking at this shouldn't look too terribly confusing. Where it does get confusing, let me jump over this relation L for 1 second. That's something we'll hit later. It's this part right here. This is the part that throws folks. If I'm talking about an ordered grouping, but it's the greater than relation, I just created the set of negative rationals. And so I say, oh no. This is the surprising part right here. This is the part that throws people, because then when they get to this exercise right here on 49, people will write wrong answers on this because they won't notice that it's saying, yeah, sure, rational number ordered group, but they're looking for the negative elements with respect to the greater than operation. I'll give you a hint on this one. Consider if I had turned it around, if I said Q with addition as the ordered group over the greater than on Q, and I wanted the positive elements. If I'm talking about the positive elements, I would be talking about all those things where this inequality fits. Give me some examples of elements here that would fit this. It's not going to be 1, 2, and 3. No. It's going to be things like -1/2 and -4, etc. Okay? Now do you understand what they're asking for on this? It can be tricky. All right. Okay, so I jumped over this for just 1 second. Relation L on Z cross Z is going to be defined as this, and this will come up on the test. So make sure you understand what I mean when I say this relation L. It's over in a component-wise system. And so we've got A, B, and CD, elements A, B, and CD off of Z cross Z. And I'll say A comma B is the L relation to CD if and only if either A is less than C or A and C are the same thing
and B is less than D. When you look at it, it makes pretty good sense. Now, but be careful when you get down to this one. Remember, your elements are in Z cross Z. So please, as you're going to do these, remember you have to have ordered pairs on this exercise. Okay, don't forget part C and D, you're going to need ordered pairs on that part of the exercise. Exercise 50 is an extra credit question. I'll leave to you. It's draw a partial graph. You're filling in the blanks, filling in the dots there for Z cross Z, the positive elements on relation L, not less than, not greater than, but that L relation you just did. Understand? All right, so moving on, I will also leave exercise 51 to you. Is less than relation in ordered group. Hopefully you will have no problem answering these questions about whether or not you are restricted to the positive elements as a group and restricting to the negative elements. It's a group. Discuss with your classmates, of course. And just one more little reminder, as you go to complete problem 54, you need to remember that this is the definition of that relation. Thank you for listening today. I know it's a long lesson. I hope to be back soon. Please complete up through exercise 45. That should keep you pretty busy. If you find yourself sitting around class right now, you should be done with exercises 1 through 55 in chapter 12. End of the chapter is coming up before you realize it. All right? I will see you soon.